In this video, we'll be looking into the introduction part of greedy approach. We'll be looking into Prim's algorithm, KRUSKAL'S algorithm, understanding it with exemplar problems. So stay tuned till the end. So let's start. Definition: greedy approach is a design technique used primarily for solving optimization problems. So it builds a solution incrementally, making a series of choices, each of which is best local option available at that particular step or time. So the central idea is to choose the most advantageous option currently available without considering future consequences. That's what greedy refers to. So this greedy choice is expected to lead to a globally optimal solution. So at every instance you find solutions, and after reaching the end, from these possible solutions you come up with a globally optimal solution. So that's what greedy approach basically speaks of. So the characteristics of greedy approach: so one is feasibility. So each choice must satisfy the constraints of the problem, ensuring that the partial solution remains valid. Yeah. So local optimity: so each choice is best among all feasible options at that particular step, aiming to lead to a globally optimum solution. So that's what we have discussed here. Then irrevocability. Next we have is irrevocability. So that is, once a choice is made, it cannot be changed in subsequent steps. Next we have, we'll understand what is the definition of feasible and optimal solution. Feasible solution is a solution that meets all problem constraints but isn't necessarily the best one. Okay, that is the solution which we get at that particular step. Then we have optimal solution, that is a solution that also maximizes or minimizes the objective function. That is optimal solution. Among the feasible solutions, we select one optimal solution. So this was about greedy approach. In exam, this could be the theory part, or the characteristics of greedy approach could be asked for 3 marks or 2 marks. Moving forward, we have Prim's algorithm. So before getting into Prim's algorithm, we should look into what spanning tree and minimum spanning tree is. So a spanning tree of undirected connected graph is a subgraph that includes all vertices and is a single connected component without any cycle. So this line is pretty important. Spanning tree won't have any cycles. Okay. So in other words, it is a tree that spans all the vertices of the graph. Here e-1 edges are present. So if you take this is a graph, but then how many edges do I have? 1, 2, 3, 4, 5, 6. 6 edges are there. But then in spanning tree, there'll be 5 edges. So 1, 2, 3, 4, and 5. So this is spanning tree. This is also a spanning tree. This is also a spanning tree. So here I have same vertices, but then the edges are e-1 edges. So that was about spanning tree definition. Understanding what minimum spanning tree is. So a spanning tree with smallest possible total edge weight. That is, the weight of tree is the sum of weight of its edges. So to identify minimum cost spanning tree manually, it is difficult. So we apply greedy method called as Prim's and KRUSKAL'S algorithm. So if we find the total cost for this particular, we have this is 10 plus 2 plus 3 plus 4 plus 5. So we would get 24 here. And on this side, if I add 16, 18, and here I would get 25, and here I would get 20 here. So among these three, we can say that from graph G, S1, S2, S3 can be the spanning trees with the T cost value which we have written. So a minimum cost spanning tree here is S3 with cost as 20. So yeah, this was about the Prim's algorithm introduction. Let's quickly look into an algorithm part now. So here we have Prim's algorithm constructs a minimum spanning tree by expanding a subtree in following manner. So there are 3 steps here. Firstly, we initialize, that is start without any arbitrary vertex. Then we grow the tree by adding nearest vertex not yet in the tree. Start from one point, then start adding. Okay, comparing the minimum. Okay. Then we repeat until all vertices are included. So looking at the algorithm part, we have input as the weighted graph v comma e, and output is set of edges comprising of minimum spanning tree. Yeah, so we take vt is equal to v naught, that is initialized set of tree vertices with any starting vertex v naught, and et is 5, that is initialized set of tree edges to be empty. Then for I is equal to 1 to v, that is, we loop through all the v minus 1 edges to the tree, and then we find the minimum weight edge, that is e star is equal to v star u star, among all the edges v comma u, such that v is in vt and u is in v minus vt. Vt, we have taken the initial set of tree vertices, right? Then after finding the minimum weight edge, we update the value. So adding new vertex u star to the set of tree vertices and adding selected edge to set of tree edges and vertices, we are updating it. Then we are returning the set of edges comprising of minimum spanning tree as the output. So this was the algorithm part. Looking at the time complexity, by using adjacency list and minimum heap, that is priority queue technique, the time complexity is order of e into log v, that is, we multiply the edges into log v times. So that is what the time complexity here is. Now let's look into the problem here. Find the statement is pretty simple. Find minimum cost spanning tree using Prim's algorithm. So we have to use Prim's algorithm here. So let's quickly here we need to compute a table. So with the table we can easily solve it. I mean, it'll become easy to understand. So here we have the tree vertices. Here I'll write the remaining vertices. Here we can illustrate it. So let's start from the first vertex. So I'm starting from A. Okay, from A, I'm initializing, start without any arbitrary vertex. So this is unknown and the path is 0. I assume it to be 0. What are the remaining vertices? I have B, C, D, B, A to B, B to F, A to F, A to E, that is B, F, E I have, and C and D are also there. So now let me write the distances. Okay, let me write the distances. A to B, what is the distance? So from A, if I go to B, it is 3, and from F, from A if I go to F, it is 5, and from A if I go to D, it is infinity because there is no direct path. And from A if I go to E, from A if I go to E, I have 6, and from A if I go to C, I have it as infinity. So out of these I should select the minimum distance. Okay, the minimum edge having minimum weight. Okay, so among this, which one has minimum weight? I can say that this has the minimum weight. So I can illustrate, I can connect this edge as A to B is 3. So this path is accepted. Okay, it is one among the minimum spanning tree. Okay, so first step I'm done. Second step, I'll go to B. Okay, B of, I have selected this now, A comma 3. So from this point I should further see now, from A to 3. Here if I write, so from B I have to C and F. C and F are there. So if I write, so from B to C, so from B to C, the distance is 1, and from B to F, the distance is 4. Yes, and from B to E and B to D, path is not there, so I need not write it. I'll write the previous values also, like this infinity values I need not write, but E and F I should write it again. That is F of A comma 5 and E comma 6. So among these, which one has the minimum value? So this we need to, as I've explained, we need to retain remaining paths in next iteration also, and we'll be ignoring the edges which would lead to cyclic tree. So that is one more point. So I'll write it here. We need to retain remaining path in next iteration and ignore edges which would lead to cyclic tree. So here I can select B to C as 1. So I started from A, I went to B, this path was 3, and B to C is 1. Yeah, so this is done. Next I have to consider this one. that is B to C 1. Now from C I have D and F 2. No, C to D if I write, so from C to D I have 6, and C to F I have 4. I will write the previous values as it is: F B comma 4, F A comma 5, E A comma 6. Here I have F from C to F as 4, from B to F as also 4. So among these two, which one will I select? So I'll select this, because from B already F is there. From B it is going to C. Now let's this again, it depends. We can select any one. Okay, so let's select this one. Okay, so I will get it as A to B I went as 3, and 3 to B to C I got 1, and C to F I got as 4. Next I need to consider this F for C comma 4 and F. So from C to F with 4. So from F I have E, A, B are already accessed, no? So I need not write it again. If I write A or B, it will become cyclic, so avoid that. Okay, next from F I have it to E. So from F I have it to E. So I'll write from F to E is 2, writing the previous values: A 6 and D C comma 6, F and 4, F A comma 5. So among these it is pretty evident from F to E has the shortest path, so I can write A to B 3, B to C I went 1, C to F I went 4, and F to E. F to E I went and it is 2. So I have covered A, B, C, F and E. Now I should write for D. Like D is not accessible, no? So let's write for D. Let me write this: E of F comma 2. So from E, if I have to reach D, I have 8 here, and writing the previous values: E of A comma 6, D of C comma 6, F of B comma 4, F of A comma 5. So I need not write this A, B, C. Sorry, D I should write, but B, A and A again I need not write. So among these two, D, C comma 6 and D, E comma 8, which one is correct? Which one is shortest value? D, C comma 6, right? So I can consider this. Check if it is forming a cyclic from D. Okay, from C it is going to D, so it is not cyclic. So I can write it as from A I went to B, from B I went to C, from C I went to F, from C I went to D also. This is 6. From F I went to E, this is 2. It is not cyclic here, so we can say that we have obtained the minimum cost spanning tree. So the graph we have obtained is minimum spanning tree. Here the number of vertices are same, so 1 2 3 4 5 6. Here also there were 6 vertices, here also there were 6 vertices. This was G is equal to V comma E. Here also V is equal to V dash. Okay, that is first point, and the edges are of minimum spanning tree are lesser than the graph, so that's what it is. If I write the total cost here, so it is 3 plus 1 4, 10, 14 and 16. So 16 is the total cost. So this was about Prim's algorithm. If you have any doubt, now let's continue with KRUSKAL'S algorithm. KRUSKAL'S algorithm is a method of finding minimum spanning tree of weighted connected graph. So it builds the minimum spanning tree by adding edges in incremental order of their weights. So the algorithm starts by sorting all edges in non-decreasing order. That is the first point. Then it initializes an empty subgraph. Iteratively, the algorithm adds the next edge from sorted list to the subgraph, ensuring that the addition does not create any cyclic graph. So as we have looked in Prim's, it has to be minimum spanning tree. That is the first condition. Second condition is cyclic should not be formed. Cyclic graph should not be formed. So that is pretty understood. Let's look into the algorithm part here. So input is a weighted connected graph. G is equal to V comma E, vertices and edges, and output is E of T, that is the set of edges comprising of a minimum spanning tree. Okay, then we have here, that is to sort in non-decreasing order of the edge weights, that is from weight of edge 1 to edge E. How many ever edges are there, we should sort it in non-decreasing order. Okay, that is the first line. Then we have E of t is equal to 0 and counter is equal to 0. That is, we are initializing the set of tree edges and its size to be 0. Okay, and E counter as 0 we are taking to keep track of number of edges which are being added to the MST. Then we have k is equal to 0, that is initialize number of processed edges to be 0. That is, this is used to iterate through the sorted edges list. Okay, this k. Then we have the while condition, that is, we are looping the number of edges in minimum spanning tree, that is the E counter should be less than the number of vertices minus 1, V minus 1, and the minimum spanning tree for a graph with V vertices should have V minus 1 edges that we know. Then if this condition is satisfied, K value would increment and move to the next sorted list. Okay, then we have if E of t union E of ik is acyclic. So we are checking if the current edge E of ik to the set E of t would form a cycle or not. So if not, it is safe, it is acceptable. But if the edge is having a cyclic graph, we need to look into the if it is forming a cyclic graph, then exit the if part, return E of t. Else, if it is acyclic, then get into further. That is, E of t is equal to E of t union E of ik. And along with that, the E counter values are also incremented. Here we are adding the edges of E of ik to the minimum spanning tree set, that is E of t, and increment the edge counter from counter plus 1, that is to reflect that edge has been added to the minimum spanning tree. And finally, we are returning the set of ET containing all the edges of minimum spanning tree. So to summarize this, I can say that first step, we are sorting all the edges in the graph. Then we are initializing empty set ET to store the minimum MST edges and edge counter, that is E counter. And next we are iterating over the sorted edges, adding each edge to the minimum spanning tree if it does not form a cyclic graph. Then after that, we are stopping when we reach V minus 1 edges. This is the fourth step, and ultimately we will return the ET value. So this was about the algorithm. Looking at the time complexity part, it is order of E into log E, that is edge sorting into union finding operation. These two are performed here. So this was about the algorithm part. In exam, they'll give you a problem to solve along with an algorithm. So algorithm is pretty small and pretty easy to understand. Yeah, let's look into the problem now. We have find minimum spanning tree using KRUSKAL'S algorithm. Question is pretty straightforward. So our first step is to identify all edges in increasing order of their weights. Step 1, to identify all edges in increasing order of weights. So here I'll be solving this KRUSKAL'S algorithm in pretty simpler terms. If you go through the algorithm, each step, k value incrementing and all, it will take time. Okay, it will take time and it will be difficult to understand also. During exams, if you write this much, whatever I'm writing, it will be sufficient enough. So let's start which edge is having the minimum weight. So if you look at this, edge 7 and 6 have minimum weight, right? So here we need to decide the source and destination also, starting and ending point also we need to take into consideration. So it could be 7 6 or 6 7. Okay, so let me write 6 comma 7, it is 2. Then I have, this is done. Next I have 4. From 5 to 6 I have 4. Next I have from 8 to 2 I have 4. Then from 2 to 5 I have 8. And from 0 to 1 also I have 8. This much I am done. Next, from 6 to 8 or 8 to 6 I have 12. Then 7 to 8 I have 14. Then 2 to 13 I have 14. Then 1 to 2 I have 16. And 0 to 7 I have 16. Next I have 3 to 4 as 18. Next I have 4 to 5 as 20, then 1 to 7 is having 22, and 3 to 5 is the maximum, having the maximum weight. It is 28. So we have sorted all the weights, all the edges initially, right? That was first step. Second step, 6, 7 is equal to 2. I am considering this as the least cost. So it will be first edge. So let me start construction. So 6, 7. So I'll write from 6, 7 will have the least cost. No. So 6, this one I should write it as it is. 6, 7 has 2. So I'm done with this. Next I have 5, 6. So I should consider 5, 6 also. So let me draw for 5, 6. 5, 6 is 4. This is also done. Now I have 8, 2. So now I should consider 8, 2. 8, 2 is 4. Done. Now I have 2, 5. 2, 5 is 8. 2 to 5. 2 to 5 is 8. So I'll consider this. Done. 0, 1. 0, 1 is 8. This is also done. Now I have 6, 8. 6, 8. 6, 8 if I consider, this will become a cycle. So I should not consider this. Next I have 7, 8. 7, 8 also if I consider, this will form a triangle. Closed. No, don't consider this. Then I have 2, 3. 2, 3 if I consider, it won't form any cyclic. It is not cyclic, no. So I'll consider 2, 3. It is 14. So I'll write 14 here. Next I have 1, 2. If I consider 1, 2, will it form any cycle? No, it won't form any cycle. So I can consider 1, 2. Here it will be 16. Yeah, I am done with this. Next I have 0, 7. If I consider 0, 7, it will become closed. No, don't consider this. Next I have 3, 4. 3, 4 if I consider, it won't form any cyclic. So I'll consider 3, 4. Now 4, 5. 4, 5 if I consider, it will be cyclic. Don't consider it. 1, 7 also don't consider it. 3, 5. 3, 5 also don't consider it. So this is the final MST which I have obtained. Okay, it is not cyclic, and this is the final MST. Note, we have to note that we should keep adding edges according to the lower costs. Okay, that is, we should keep adding edges according to lower costs. So, and again, it should not be, it should be a cyclic graph. So if we calculate the total cost here, step 3, to calculate the total cost, I have 8 plus 16 plus 4 plus 2 plus 4 plus 8 plus 14 plus 18. If I calculate this, I get 74. So this was about KRUSKAL'S algorithm. I hope you have understood all the concepts. If you have any doubts, do let me know in the comments. We have also looked into Prim's algorithm in this video, and we have understood the basic introduction of greedy approach. So stay tuned. If you have any doubts, do let me know in the comments, and subscribe to my channel. Thank you.